Welcome to our Scientastic class. I'm teacher Bridgeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together. Let's have a short recap. What is the second law of motion?
Law of acceleration. It states that the acceleration of an object is directly proportional to the net force applied on it, and inversely proportional to its mass.
Very good. Acceleration depends on two variables. What are they?
Ma'am, one is net force and the other one is the mass of an object.
Correct. Do you know the sports sumo?
Yes, ma'am. This is a heavyweight wrestling which wrestler wins by facing his opponent outside a circle.
Yes. This is a Japanese full contact sport. Two wrestlers attempt to overpower each other with aims of getting their competitor out of the ring, or for any part to touch the ground other than the soles of their feet. Try to imagine yourself as a sumo wrestler in a match. What would you feel?
Ma'am, I would feel my opponent's force towards me.
Of course, that is also the feeling of your opponent. As you strike and crush each other, you would feel the force. When he applied force towards you, the same goes for applying force to him. In other words, there is a pair of forces in the sports sumo. Sir Isaac Newton realized that every force occurs in pairs, and an isolated force does not exist by itself. He therefore formulated the third law of motion, the law of interaction. The law of interaction is also known as the action and reaction. The third law can be briefly defined as, for every action, there is an equal and opposite reaction. According to this law, action accompanied by reaction force and the two forces must be equal and opposite. For example, the boy pushes the wall. Law of interaction states that if body A, which is the boy, exerts a force on body B, which is the wall, then body B, wall, will exert a force of equal magnitude on body A, boy, but in opposite direction. Another example, deflating a balloon. Reaction, when balloon goes up, and action, air rushes down. Action-reaction forces do not cancel each other since they act on two different objects or systems. Let's have an activity. You are going to tell me what is the action and reaction of the following.
Action, when the swimmer pushes against the water. Reaction, water pushes back the swimmer. Action, ball puts a force on the wall. Reaction, the wall puts a force on the ball and it bounces off. Action, hammer pushing the nail. Reaction, nail pushing the hammer.
This is all for today, class. See you on our next video. Bye!